Hello and welcome back. This is the second part of the grappling gun tutorial. We will finish up the whole script in this part. We're going to finish the server script and we're going to finish up the module script. We no longer need this local script. Actually, we will later, but we can ignore the local script for now. I'm actually just going to keep that open so I can remember. So in the tool module, we're going to write a couple of functions, but we're also going to write a couple of defining variables for the tool. We're going to do tool.canActivate equals true, tool.range equals 75. You can make this whatever you want. This is going to be in studs, and tool.timeDivider equals 80. You can make this whatever you want as well, but I recommend making it higher than the range. We're going to write a couple of functions. We're going to do function, not local function, just global function, because it's in a module script. Tool.getDistance. We're going to have origin and target. Origin and target are the two parameters, and if we type a colon outside of the function's parentheses, we can tell it what it's going to return. So I'm going to do colon number, because it's going to return a number. Origin is going to be a vector 3, and target is also going to be a vector 3 value. So what we're going to do is local magnitude return magnitude. So now we're going to do local magnitude equals 2 parentheses, origin minus target, outside of the parentheses, dot magnitude, and then we return the magnitude. Now we're going to need another function, function tool.setCanActivate. We're going to need the player, and value, which is a boolean. Tool.canActivate equals value, so we're going to set it to this boolean, because tool.canActivate is a boolean. Next function we're going to need is function tool.getRange. We're going to need the player, return tool.range. Now we're going to need function tool.getStatus, which is going to be a very, very big function. It's going to look very scary, but I will do my best to explain it. But we're going to need the player, which is player, mouse target, and mouse hit. We'll do that in a minute because we need to define this function first, this next function first. So function tool.part can attach. Part base part, which is going to return a boolean. And first of all, before I go show you in the workspace, we're going to do if part has tag. So it will check if the part has a tag labeled can underscore attach. Then return true, else return false. So what I'm going to do is in the workspace, I'm going to add a folder. Just going to keep it named folder. It doesn't matter. I'm going to insert a part, put that in the folder. Anchor, cast shadow, false. Color, I don't know, blue. Now this is going to be the part that we test with, but what I'm going to do is up here in view, I'm going to add command bar. And in the command bar, I'm going to type workspace.folder.part add tag can underscore attach. And what that's going to do is it's going to add a tag to it, which you can't see, but it has a tag that the module script is going to check for. And what this is going to do later in the tool is it's going to check if the part has the tag, then it will let you attach to it, otherwise it won't. Now in the tool module, I need to copy that string from the last part of this tutorial. We're going to check if if tool.canActivate then. And then we're going to write else return, paste the string in Now this string is the text of the text label that is in the tool. It is the text of this. Next thing we're going to do is if mouse target, then else return that string. This will also be in the description of the video as it was in the first part. Then we're going to type if tool dot part can attach mouse target, then else return that string. And first of all, before I continue, I'm going to explain what the backticks are. There are multiple ways to write strings in Roblox Studio, and I'm using backticks so it doesn't mess up with these quotation marks. Because if I use just regular quotation marks, it's going to mess with the string because it has more quotation marks that are setting like the thickness, the transparency, the RGB on those two things. So the backticks will encase it into one string and the quotation marks won't mess with it. There are multiple ways to write strings. You have backticks, you have two backticks, two quotation marks, two apostrophes, two open square brackets, and two closed square brackets. And these are the 4 ways that you can write a string. I chose backticks for this. Now in the part if it can attach, then we're going to get local distance equals tool.get distance. We're going to do script.parent and wait for child fire point dot position, and then we're going to do mouse hit dot position because mouse hit is a C frame, so it has a position value. So now we're going to check if distance is less than or equal to tool.range, then else if distance is greater than tool.range, then. In the else if, we're going to return the string that says no, but up here in the if distance is less than or equal to, we're going to return that string, but I'm going to edit the string. Right here where it says font color equals RGB, I'm going to change it from 2557575 to 100 255 100. Then it has to have commas. And I'm going to change no to yes. And that's a very big function, and it seems very scary, but hopefully you're able to understand what it does. And I hope I explained it well enough. Now back in the main script, we're going to write the condition function. The first thing we're going to type is if not module.can activate, then return end. Keep it all on one line. Module.can activate equals false. If mouse target and mouse hit, so if mouse target is not nil and mouse hit is not nil, then we're going to continue. And if module, actually first we're going to do else return, so it will cancel the function. It will exit and stop running. But back in the if statement, just above the else, we're going to type if module.part can attach mouse target, then else return. Above the else, we're going to get the distance, so local distance equals module.get distance, firepoint.position, mouse hit.position. So just like we did in that module script with the get status, the status function, we're going to do that exact same if else if statement too. So if distance is less than or equal to module.range, then fire. And this is going to pass player, so PLR, mouse target, and mouse hit. as well as distance. We're going to pass the distance function, distance variable. So just above the local condition function, we're going to type local function fire. This function is going to seem pretty complicated, but it's just a lot of code. It's more code than it is complicated. So we're going to do plr player, player. So plr player, comma, mouse target, comma, mouse hit, comma, distance. Now this function, like I've already said, takes a lot of code. So first thing we're going to do is sounds, wait for child, fire, play, character.primary part.anchored, so the player won't be able to move. So then we're going to do local attachment part. I'm just going to copy this, equals instance.new part in a string like that. So we're going to do attachment part.name equals attachment part. Attachment part.can collide equals false. Attachment part.orientation, so if it ever gets messed up, equals vector3.new 0,0,0, reset it. Then we're going to do attachment part.size equals vector3.new 0.3, 0.3, 0.3. So it'll be really tiny. Then it's going to be attachment part.position equals firepoint.position. Attachment part.transparency equals 1. Attachment part.cast shadow equals false, even though it's transparent. Just want to make sure there's no shadow. Attachment part.anchored equals true, so it won't fall out of the sky. Attachment part.parent equals workspace. That was a lot for one part. We're going to need 2 attachments. So local attachment 0 equals instance.new attachment. Attachment 0.name equals attachment 0. Attachment 0.parent equals firepoint. Now we did another attachment, so local attachment 1 equals instance.new attachment. Attachment 1.name equals attachment 1. Attachment 1.parent. And this is going to be equal to that attachment part. Now we need the rod constraint, which is... it's kind of hard to explain, but I will show you visually. So I have one part here. And this part, I'm just going to set its position to be like that. This one part, well, these 2 parts rather, have a gap between them. But if I go up to the model tab, right under here where this create is in a rod, then we can add 2 attachments here, and we'll create a rod between them. And what this will do is no matter what position these 2 parts are at, this rod will always follow the attachments, which is really useful for what we are trying to do. So we're going to need local rod constraint equals instance.new rod constraint. I'm going to copy the name. We're going to do rod constraint.color equals brick color, because the color of a rod constraint is a brick color. So brick color.new. I'm going to pick ghost gray, so it's like a nice whitish gray. We're going to do rod constraint dot visible equals true, because by default, when you're using instance.new, rod constraints have the visible property set to false, so you can't see it. So then we're going to do rod constraint dot thickness equals 0.08. It doesn't need to be ridiculously big. Rod constraint dot attachment 0. This is where those 2 attachments come into play. So attachment 0 equals attachment 0. Rod constraint dot attachment 1. Attachment 1 equals attachment 1. Rod constraint dot parent equals fire point. So we're done creating those 4 instances. So what we're going to do now is calculate a time, and we're going to create a tween info and then create a tween on the attachment part with that tween info, and it's going to set the position to the mouse hit position. So what we're going to do is we're going to do local time underscore equals distance divided by module dot time divider. This helps so it takes roughly, at least visually, the same amount of time to get from one place to the other. No matter what the position is, it would take what would look like an equal amount of time to get there. So now we need to create the tween info, so local info equals tween info.new. We're going to put in time underscore comma easing style, which we have that variable from. Now we're going to create local tween equals tween service colon create. We're going to create it for the attachment part. It's going to be the first parameter. Then info for our tween info. And the property table, you want 2 curly brackets like this. Position equals mouse hit dot position. Because mouse hit is a C frame, we want the position from the C frame. Then we're going to do tween colon play. And tweens have a special event called tween.completed when the tween finishes playing. So we're going to utilize that so we can wait for it to finish instead of just waiting the amount of time. So we're going to do tween.completed colon connect function. We don't need that playback state because it's useless for what we're doing. Task.wait 1, so we're going to wait 1 second, and then reset. This is going to take the time, the attachment part, the attachment 0, attachment 1, and rod constraint. That we're going to create a function with this name. You can name it whatever you want. I'm going to name it reset. So above the fire function, we're going to create a new function, local function reset, and this is going to again take time, which is a time underscore, which is a number, then the attachment part, which is a base part, which is just a category of every part type, and then we're going to do attachment 0 colon attachment 1 colon attachment, and then rod constraint colon rod constraint. Now in this function, it's going to be a little bit more complicated, calculating wise at least, for some specific things, but we're going to create yet another function. This one is going to be called local function set player collision. Just making sure I'm spelling it right. Can't think properly. Value colon boolean, because it's going to be a bool value. So we're going to get every part in the character, and everything that is a child of the character, not a descendant, so not a child of a child, just the immediate children of the character. So for underscore comma v in character colon get children do if v colon is a base part. So we're going to check if it's a part or a mesh part. Then if v.name is not equal to humanoid root part, because for both R6 and R15 characters, the humanoid root part is collision is always set to false. Then, or I might have that backwards, I don't know. v.can collide equals false. So now we're finished with that function. It's very simple. Not equals false. That was almost very bad. We're gonna do v.can collide equals value instead of just setting it to false. Now, in the reset function, we're going to call the set player collision function. We're going to set it with false. Then we're going to define 3 values that are going to be equal to nothing. So local vector, which is going to be a vector 3, local pause for position, and local CF, which is C frame. Now, this is going to be complicated. Stick with me, just type exactly what I'm typing, and you'll be okay. If character.humanoid.rig type equals enum.humanoid rig type .r6, then vector equals negative attachment part .cframe .up vector. So the up vector, every C-frame has multiple values that you can see here. It has the position, which is just the position, like just part dot position. It's the same thing as C-frame dot position. It has the position, is the look vector, so it's where the part is looking, the front face is looking. Then it has rotation, so the rotation of the part has an X value. It has up vector, which, like look vector, it's where the top of the part is. So it's at the very top of the part. So we're going to do negative up vector to make it the bottom of the part. Then there's right vector, which is the right of the part. So if you were to do negative right vector, it would be the left. And then there's y, z, x vector, y vector, z vector. I've never used x, y, or z vector, but we're going to do negative attachment part .cframe .up vector. Now we're going to do pause equals attachment part .position plus vector. This would be the same as if you just did attachment part .position minus attachment part .cframe .up vector, but I like to do it this way. Then we're going to do cf equals cframe .new pause. We're going to create a new C-frame with that position. Drop a line. Else if character.humanoid.rig type equals enum.humanoid rig type. Make sure this is equals humanoid enum.humanoid rig type .r15. Then vector is going to be the same thing. So vector equals negative attachment part .cframe .up vector. Now this is where it gets a little bit more complicated. Pause equals attachment part .position plus vector. Then after the plus vector, we're going to do space minus 2 parentheses character.humanoid root part .size divided by 2. Outside of those parentheses, we're going to do minus character.head.size. So it will be, so if your game is R6 or R15 or custom, it will work for both R6 and R15. Since R6 primary parts are by default the head, and by default for R15 it's the humanoid root part, we're just doing a little bit more math, so it would put you in the same position as it would if you were R6. Now, outside of that if and else if statement, we're done with that. What we're then going to do is create another tween. We're going to tween the tool back to where the attachment part is. So it will move you to where you grappled. So local new time equals time underscore multiplied by 2. So double the original amount of time that it took to get there. Then we're going to do local info equals tween info dot new time easing style easing direction. And we're going to create another tween, so local tween equals tween service. My mic is kind of far away, I apologize. Tween service colon create character dot primary part info 2 curly brackets again to create a table. C frame equals cf tween colon play. Now again, we're going to use tween.completed, so tween.completed colon connect function task.wait 0.5, so we're going to wait half a second. Attachment part colon destroy attachment 0 colon destroy attachment 1 colon destroy rod constraint colon destroy. Now we're going to unanchor the character, so character.primary part dot anchored equals false, set player collision true. So we're going to call that set player collision function we wrote earlier, and we're going to pass true, so it's going to make them collide again. Now we just have one more thing that we need to write in the local script, which is going to be for when the character lands and touches the floor. We're going to do humanoid. Let me adjust my keyboard. Humanoid, that's state changed, connect, function. This is going to have two parameters, old and new. If old equals enum.humanoid state type dot freefall and new equals enum.humanoid state type dot landed, then if is equipped, then remotes wait for child set can activate fire server true. Now there's a couple more things in the script that we need to finish connecting from the last part because we didn't have those functions yet. We're going to set the can activate remote event. The function is going to be module.setCanActivate. Remotes wait for child get range.onServer invoke equals module.get range. Remotes wait for child get status on server invoke equals module get status. And now we have completed our tool. The grappling gun officially works. I'm going to put the tool in the starter pack, and when I join the game, it should work. If there's any errors, I will help guide you to fix them. Okay, so I'm going to walk up. I'm going to take out my grappling gun. Ooh. There we go. There is an issue. Let me go look at the script. I see what I did wrong. I forgot to create the C-frame in the checking if you're R15. So in the else if statement, if else if character.humanoid.rig_type equals humanoid.rig_type.r15, then cf equals cframe.new pause. I forgot to create the C-frame, so it wasn't moving the character. The status I also noticed was a bit bugged, but we can figure that out as well. But now it works! Okay, so I have found my error with the get status. I forgot to connect it to run service. So what we're going to do is run service.renderStepped, connect, render stepped, and now the whole tool will work. See, now the text label works. If I do it from way over here, I can do it from way over here, and it will take me up. That wraps up making this tool. I would like to say thank you for joining me in part 1 and in part 2. If you were able to understand a good chunk of it, you just learned a bunch of fundamentals of scripting in Roblox. I want to say congratulations to that, because if you're new to scripting, learning how to script is a big accomplishment. I hope you join me in my next video, which will be next week on Thursday. I'd like to thank you again for watching. Goodbye.